Vansika, keep continue. Good morning, students. How are you all? Okay, so today we will keep continue. We have done 5 questions of the chemical bonding, and today we will do the remaining question. Okay, so our next question is the ion which is isoelectronic with CO. First of all, we will see how many electrons are present in CO. Okay, so here in carbon monoxide, carbon, what is the atomic number of the carbon? 6. So 6 atomic number means electrons are also 6. And oxygen, what is the atomic number of oxygen? 8. So 6 plus 8. Total electrons are 14. So there are total 14 electrons. Now you will see the options in which there are 14 electrons. Here Cn negative, carbon 6 plus nitrogen 7 plus 1 negative charge is here, means 1 more electron. So 6 plus 7 plus 1, 6 plus 7, 13. 13 plus 1, 14 electron. So I think this is the right option for this. Okay. So we can see other options also here. Oxygen. One oxygen has how many electron? 8. But it is O2. There are 2 oxygen. So 8 plus 8. Plus 1 negative charge. So 1 more electron is here. Total 8 plus 8, 16 plus 1, 17 electrons. And here, Karan, tell me, what is the atomic number of nitrogen? 7. There are 2 nitrogen, so 7 plus 7. Plus 1 positive charge. 1 positive charge means 1 electron less, so minus 1. So there are 13. And here, 8 plus 8 plus 1 positive means 1 less electron, so 15 electron. So which one is isoelectronic? Means same number of electron. So which one species is isoelectronic? In CO there are 14 electrons, and Cn negative, it also has 14 electron. So option A, this is the correct option for this question. It is clear to you or not? Yes. Next question is the correct bond order in the following species is. Students, here species are given O2 plus O2 negative and O2 2 positive. We will see the order of the bond order. You know bond order of isoelectronic species. Of isoelectronic species will be same. If number of electrons in 2 species are equal, then their bond order will also be the same. Okay, so again we can see the number of the electrons. Okay, students, so here we will see, but here we should tell about the bond order, their correct orders. How can we tell? With simple trick. With simple trick. We have already seen the molecular orbital theory. On behalf of molecular orbital theory, we can tell about the bond orders. But here by using simple trick only, we will find out the bond order. If number of electrons 9, 10, 11, 12, 13. Here, bond orders. If electrons are 9, then bond order will be 0. If electrons are 10, then bond order will be 1. Then you will increase by 0.5. So here, if 11, then it is 1.5. Then again increase by half, then it is 2. Then 2.5. Then 3. Then 3. After increasing up to 3, you will start to decrease by 0.5. Clear or not? Then 2.5, 2, 1.5, 1, and if electrons are 19, then 0.5, and if it is 20, then it is 0. Clear or not? So here, you will calculate number of the electrons. In case of O2 plus, how many electrons? O2, 16 electron plus 1 charge. So here minus 1 electron we will do. So how many electron? 15. Here 16 plus 1, 17 electrons. And here 16 minus 2, because 2 positive charges here. So here 14. So students, what will be the order of the bond? For 15 electrons, bond order is 2.5. For 17, bond order is 1.5. For 14, bond order is 3. We have to arrange them in. So here increasing order is given to us. So we will see maximum bond order for O2, 2 positive, it is 3. Then for O2 plus, it is 2.5. And then O2 negative, it is 1.5. So this should be the order. This should be the order. Clear or not? So see, you have any option here or not? Which one is the B? Option B is the right option for this question. So students, directly you can see the number of electrons in given species. On behalf of that, you can tell about the bond order. Okay, and then you can arrange. Clear to you or not? This question is clear or not? Sometime if it is asked, what is the order of bond strength? Bond strength is also directly proportional to the bond orders. So we can also write the same orders. Clear or not? Sometime if it is asked what will be the order of bond length, then this order will be reverse, because bond length is inversely proportional to the bond order or bond strength. Clear to you or not? Yes. Now our next question is, which of the following molecule have trigonal planar geometry? We have already done Vesper theory. Okay. So trigonal planar. Trigonal planar geometry. What type of geometry it is? If it is A, it is forming 3 bonds. Then this type of geometry, it is trigonal. Okay, and it is planar because all attacking molecules, attacking atoms, ions are arranged in the same plane. Clear or not? Here, no one is out of the plane. So it is known as trigonal planar structure. And you know very well, students, when hybridization is sp2, then geometry will be trigonal planars. Clear or not? And angle, what should be the angle between them? Angle will be 120. Angle will be 120. Clear or not? And you know very well, how can you tell about the hybridization? In hybridization, we will see number of bonded atoms plus number of lone pairs if their sum is 3, then hybridization will be sp2. Clear or not? So now you will see this. In case of BF3, you know very well boron. Boron atomic number is, what is the atomic number of boron? 5. It is 5. So its valence electron are 3. So how many bonds it can form maximum? It can form maximum 3 bonds. And here number of bonded atoms are 3. So number of bonded atoms are 3 in case of BF3. All electrons are consumed in formation of bond. So lone pair is 0. Overall this sum is 3 plus 0, 3. So here we can say BF3. It is trigonal planar. Clear to you or not? You can see others. Option also. This is NS3. Central atom is nitrogen. So here nitrogen has atomic number 7. Then 2, 5. Valence electrons are 5. So it can form maximum 5 bonds. But it is forming only 3 bonds with 3 hydrogens. Okay. So it is forming only 3. So number of bonded atoms are 3 here. 2 electrons are non-bonding. 2 electrons are forming 1 pair. So lone pair is 1. So here this sum is not 3, it is 4. And 4 hybridization will be sp3. And if hybridization is sp3, means its geometry will be tetrahedral. Same, because nitrogen and phosphorus both belong to the same group. So again here also 3 bonded atoms, so hybridization will be sp3 again here. Clear or not? In case of IF3, iodine is the central atom, and you know very well iodine is halogen, and halogens in which group they present? They belongs to the group number 17, and in group number 17 how many valence electrons? 7. There will be 7 valence electrons. So valence electrons are 7, and you know very well fluorine is univalent. Fluorine can form only 1 bond. Okay. So here number of bonded atoms are 3 only. Okay. So 7 minus 3, 4 electrons are remaining electrons. They are non-bonding, and 4 electrons are forming how many bonds? How many pairs? They are forming 2. Okay. So lone pairs are 2. So here bonded atom 3 plus lone pair 2. So 3 plus 2, 5. So hybridization 1s, 3p, 1 plus 3, 4, and 1d. So hybridization will be sp3d. Clear or not? So here hybridization is sp3d. And students, If hybridization is sp2, if hybridization is sp2 and no lone pair should be there, you will keep in your mind, because this is a regular geometry. Clear or not? If lone pair is there, then your structure, your geometry will be distorted. So if hybridization is sp2 and number of lone pairs are 0, then geometry will be trigonal planar. And which option satisfies these conditions? These are followed by the A. These are satisfied by BF3. So option A, BF3 is the right option for this question. It is clear to you or not? Yes. Now our next question is, in which of following pair the two molecules have identical bond orders? I have already told you that bond orders. Bond order will be same when if number of electrons in two species are equal. If number of electrons in two species are equal, then their bond order will be same. Okay. So here again, by counting number of electrons only, you can tell about the bond orders. Okay. So which one has identical, means same bond order. Here N2, how many electrons are there? 14. And in O2, 2 plus. How many? In O2, 2 plus. So in one oxygen, atomic number 8, so electrons are 8, but oxygen are 2, so electrons are 8 plus 8. But 2 positive charges here, means it is losing 2 electrons. Okay, so we will subtract 2 electrons. Minus 2 we will subtract. So here 8 plus 8, 16 minus 2, 14. Here also 14. Clear or not? Now in second option, N2 14 or to 16 plus 1 minus, so 17. Here 14 plus 1, 15. Here 16. So here 16 plus 2, 18. Here N2, 14. So which pair has same number of the electron? A. In A, N2 and or 2 positive, both have same number of electrons, 14 electrons. So their bond order will also be same. Bond order also they have same. So here option A will be the right option for this question. Clear to you or not? Any doubt? Yes. Now last question for today. Which one of them is weakest? Tell me, ionic bond, covalent bond, metallic bond, van der Waals force. Which one is weakest? Van der Waals force of attraction, because it is not a permanent bond, it is just an interaction. Clear or not? So it is weakest. Here van der Waals is the weakest because it is only a attraction, it is not a bond. Clear or not? So students, we have done 5 questions today. So any doubt in any question? No. Okay, so thank you, have a nice day.